congruent. In order to be able to do that, we need to go back and review some of our vocabulary from previous lessons so that when we get to writing proofs, we'll know how to do it. So we're just going to start with little bitty baby proofs, little single step. Why do we know what we know? So a proof is just a logical argument that proves a statement is true. So I have some given information and I just want to prove that something is true. And we're going to do these as 2-column proofs. And so in every 2-column proof, we have one column that has our statements and one column that has the reasons that go with them. So it's basically, what do I know and why do I know what I know? That's what we're trying to do. So we're just going to start really basic with some things about why we know what we know. So the first one says DB, which is a segment. So this DB right here bisects angle ADC. So angle ADC. And I think it's always good. It's good practice to draw on the picture so that you can see. So this line right here, DB, cuts this angle in half. That's what bisect means. Bisect means to cut in half, or to cut into 2 equal pieces. Now I cut an angle. Now this is important. When I cut an angle, I get 2 angles. So I have cut an angle in half, which is going to result in 2 angles. So if you just look at the pieces that we highlighted, then when I use DB to cut that in half, then I'm going to end up with angle 5 is congruent to angle 6. Why do I know that? Because that is the definition of angle bisector. An angle bisector cuts an angle in half. So when I bisect an angle, I always get angles back. So let's look at this next problem. See, we're just going to do little baby steps right now, just little things. So right now, that's the important word, angle bisector. So that was our vocabulary word that we went over. So the given part is that angle 3 on this number 2, angle 3 is congruent to angle 4. So let's go over here to our picture and let's look. Angle 3 is congruent to angle 4. Now, think about it. Why do you know? Why can we say that angle 3 is congruent to angle 4? Well, angle 3 and angle 4 are vertical angles, and we know that vertical angles are all congruent. So that's what we would say. Vertical angles are congruent because those angles are vertical and vertical angles are congruent. See, we don't want to just say that they're vertical angles because I have said that they're congruent, so we need to talk about the fact that they are congruent. So there is another vocabulary word, vertical angles, and knowing what those are. So let's look at number 3. B is the midpoint of AC. So I go over here and I look. B is the midpoint of AC. So what that is that's the middle of a segment, okay? AC is a segment. So when you are in the middle of a segment, you get 2 segments back. So when you bisect an angle, you get angles. When you bisect a segment, you get segments. So what segments are equal? Well, AB would be congruent to BC. So we could say that AB is congruent to BC. Why do I know that? Because that's what midpoint means. Definition of midpoint. So there's another vocabulary word, midpoint. Now, this next one is it may be a little bit new. You've probably talked about properties before, but we haven't used a lot of it in here. But DB is equal to DB, which is kind of a funny thing to say, but it's important because if you look, you have 2 triangles here, and this is where we're going to need it later. You see this triangle ADB, and then we also have this triangle CDB, and see how DB belongs to both of them? So sometimes we have to state that. So DB of the pink triangle is equal to or congruent to DB of the yellow triangle. So we'll kind of color code this so that you can make sense. So DB of the pink triangle is congruent to DB of the yellow triangle. That is called the reflexive property. It sees itself. So when you look in the mirror, you see yourself. So anytime you have a statement where itself is equal to itself, it's called the reflexive property. Now, these next two have to do with perpendicular lines and right triangles. And the reason is because there are going to be certain kinds of proofs that we have to write that have to do with right triangles. So we're going to work our way into that. So right now we're just going to talk about the two possible things that can happen when you have right angles. So the first thing, it says that DB is perpendicular. That's what that symbol means right there. So perpendicular. Lost track of my spelling. Perpendicular. DB is perpendicular to AC. So the first thing that we want to mark is what that means. So DB is perpendicular to AC. So we mark it right there. So that's given. That's what we've been told. Anything given is what we know for sure. We've been told that. So what that means is that angle 1 and angle 2 are right angles. Now, the reason we know that is because that's what perpendicular means. Perpendicular lines are lines that intersect at right angles. So definition of, and you can do the symbol for perpendicular as long as you remember what that means. Okay, definition of perpendicular. Perpendicular means two lines that intersect at right angles. So I can say that they are right angles. And then I can say that angle 1 is equal to angle 2. Well, that makes sense. If they're both 90 degrees, then they're both equal to each other. So angle 1 is congruent to angle 2. Now, why can I say that? Because of this. All right angles are congruent. So that's the phrasing that we'll use most of the time, all the time with this, is all right angles are congruent, or right angles are congruent. It doesn't matter where they are. Right angles are right angles. They're all 90 degrees, and so they're always the same size. Now, we usually skip straight to, somebody will say those lines are perpendicular, and we skip straight to 90 degrees. We skip straight to saying that they are 90 degrees. But technically, the definition of perpendicular says they're lines that intersect at right angles, and then we have to say that they're 90 degrees because they're right angles. So lines that are perpendicular form right angles. Because they are right angles, they are worth 90 degrees. And so we have to go through that process. But we often skip straight from perpendicular straight to 90 degrees. But there is a middle stop that we have to go through. And that's important because of this next step that we're going to say. So if I, again, notice this is very similar. DB is perpendicular to AC. So we have the whole thing over again. Okay. Angle 1 and angle 2 are right angles. And I can say that because of the same thing, definition of perpendicular lines. Because lines that intersect, that are perpendicular, intersect at right angles. And so the only thing I can say is that they're right angles. Now, because they are right angles, I am allowed to say that ABD, this pink triangle right here, and DBC, this orange triangle right here, are right triangles. Now, you'll understand more about this later, about why we need to have the distinction between the two of them. Sometimes we need to talk about the angles, and sometimes we need to talk about the triangles, and that's the difference between these two. This one I'll use in a situation later on in this unit where I need to talk about the angles. This one I will use when I need to talk about the triangles being right triangles. And I know that those are right triangles because by definition, a right triangle is a triangle that has a right angle. So since they have right angles, they are right triangles. So it's a definition of right triangle. We can shortcut it like that. So remember, the definition of perpendicular is lines that intersect at right angles, which means that they are 90 degrees. The definition of a right triangle is a triangle that has a right angle in it. So since it has, we have to say that it has a right angle, and then we can say that it's a right triangle. So these are just kind of an introduction to the kinds of things that we're going to be looking at later when we get to proofs, but we wanted to just do it one step at a time and get some of those vocabulary words back in your mind, like angle bisector, vertical angles, midpoint, the reflexive property, right angles, right triangles, perpendicular. So we've got some vocabulary here. We've got perpendicular, we've got right angles, we've got right triangles. So all of those are vocabulary words